Hey John, how's it going? This is the introduction to the chapter 12 material, which has to do with trig identities again. So I think that we had a unit, maybe it was chapter 10, that we were doing trig identities, and this stuff, yep, this information comes right back again in chapter 12, so hopefully you still remember it. I think you do because I think it was only like a week ago. But this chapter in itself is really easy. It's not that hard. It's not going to take that long. I actually might even be able to get through all of the notes for this entire chapter, this entire unit, all today. So if that's the case, that's awesome. Once you watch these videos, you can go right ahead and take the chapter 12 test. My goal, just so that you know, is to post all of the videos that are necessary for you to get through the information from chapter 12 all the way through chapter 16, which is the very last chapter that the kids are doing right now. So I'm going to post all of those videos for you, hopefully in the next week or week and a half. Watch them whenever you can, as soon as you can. Take those tests and then get them back to me. You got a 70 on the chapter 9 test, I think it was. Yep, on the chapter 9, and the identities, which is awesome considering the fact that we did it in like a week. So that is really, really good. I'm really, really impressed with your ability to get a 70 on that. So what I need from you, watch all these videos as soon as possible, take the test as soon as you feel comfortable, and get me tons and tons of homework assignments, okay? This is totally up to you. You need to be responsible and get that stuff in. You know, even if you don't feel good and Abby isn't tutoring you, maybe she could just swing by and pick up if you have a bunch of homework assignments for her. I still really, really think that you are capable of taking the Regents exam in 2 weeks from now, okay? So let's talk about the chapter 12 information. So it has to do with trig identities yet again. So let's just review what those are. There's only a couple of them. The first ones are the reciprocal identities. So cosecant is 1 over sine theta. Secant is 1 over cosine theta, and cotangent is 1 over tangent theta. You already know these. You got this under control. I'm positive about that. So let's move on. Quotient identities, same thing as before. The only reason why I'm reviewing this is because we're going to use these in the next step. So I'm just going back through them really quick. Tangent is sine theta over cosine theta. Cotangent is cosine over sine theta. You already know those. If it's hard for you to remember this one, just remember cotangent starts with a C and the cosine starts on top. Okay? Not that bad. And then Pythagorean identities. We have sine squared theta plus cosine squared theta is equal to 1. That's the most basic identity that everybody needs to know and remember. And then the other two that follow are listed right there. You should have these written down already. If you don't have them written down yet, you can write them down in your notebook or somewhere. But let's just talk one more time about how we actually get those other two identities, okay? So sine squared theta plus cosine squared theta is equal to 1. That's the most basic one that everybody should have memorized by now. So sine squared theta plus cosine squared theta is equal to 1. Now, in order to derive the other two equations, you're going to use this first one and then do 2 steps. You're going to go through and divide everything through by sine and see what you get. And then the second time you're going to go through and divide everything by cosine and see what you get. So let's divide by sine squared first. Okay, so we have sine squared theta divided by sine squared theta. That is just equal to 1. Cosine squared theta divided by sine squared theta. That is equal to cotangent squared theta, which is the identity that we just talked about. And then the last term, 1 divided by sine squared theta, that is cosecant squared theta. Okay. Hopefully yours is a little bit neater than mine. I'm really sorry. Okay, after you go through and do that, you can now go through and divide everything through by cosine squared theta and then see what you get when you do that. Okay, so I'm going to divide by cosine squared theta for every one of these terms. Okay, so sine divided by cosine gives me tangent squared theta. Sine divided by, or I'm sorry, cosine squared divided by cosine squared is just 1, and 1 over cosine squared is secant squared theta. Okay. So those two identities are the second two listed right here and right here. That's where we get them from on your test. If you can't remember the second two, go through and do exactly what I just did and just derive them on your own. Okay? So that is the list of the identities that we need to know for this chapter. Pythagorean identities, reciprocal, and quotient identities. Okay? There aren't that many of them. I think there's only 8. Okay. What we're going to talk about now is proving trig identities. And most people didn't really like to see this because they see the word prove and they're thinking proof. And that's exactly what we're going to do. We're going to do a proof. But we're not going to do an ugly proof like what you saw in geometry. In geometry, in order to prove something, you had to go through all of these steps and you had to remember all these theorems, and it was just really ugly, and you had to give a statement and a reason, and this is nothing like that at all, okay? All you're doing is proving a statement, and I'm going to show you what I mean. So let's just take a look at these notes really quick. We're going to check to see if the identity is true. What that means is I'm going to give you an equation, like, for example, a really easy one would be cosine squared theta plus sine squared theta is equal to 1. And you're going to have to manipulate it in some way in order to prove that, yes, it really is equal to 1. Okay. Your goal is to make both sides match. When you do this, you're going to have something is equal to something else. Your goal is to make both sides match each other. Now, you're only going to go through and change and manipulate one side, leave the other side the same, and I'm going to show you what I mean. You're going to pretty much take the more complicated side of the equation and manipulate it somehow in order to make the other side equal. There are some things that you are allowed to do with proofs and some things that you're not allowed to do with proofs. You are allowed to do substitutions and cancel things out. That's like mathematically, I don't know, legal in this case, okay? But what you can't do, normally with equations, we move things over from one side of the equal sign to the other. So if we're adding 4 to both sides, or we're subtracting 4 to bring it over, something like that. That's not legal. It's not allowed in this case. The only reason why is because I want to manipulate this side of my equation to make it match the other side. I'm not moving things back and forth. And I'm going to get to that again. I'm going to show you what I mean. You're going to always work with the more complicated side of the identity. It's 99% of the time it's going to be clear about which side of the equation that you want to be changing. Okay, and I'm going to show you what it means. It's really hard for me to go through all this stuff when you don't have an example in front of you, but just bear with me 1 second. Your first step is always to write things in terms of sine and cosine. You've heard me say that 100,000 times. Sine and cosine are our most basic elements. It's like x and y. So the first thing you're going to do in order to simplify an equation is write everything in terms of sine and cosine. That's it. And then, if there's a squared term, check for a Pythagorean identity. I've kind of already talked about that with you, because whenever we were doing those equations, and I said if you see something that's squared, or if you see something like 1 plus or 1 minus a term that's squared, check your Pythagorean identity list, and more than likely it's going to be something on there. Same thing goes here. This chapter is really easy because you've already done a lot of this stuff. Okay. When you are finished, or you are finished when the left side exactly matches the right side. Okay. Feel free to go back through those notes. Maybe after you see an example, you can always rewind the video and watch that again. But I'm going to keep moving on, and we're going to do an example, I think. Okay. We are going to prove cosine theta plus 1 divided by 1 plus secant theta is equal to cosine theta. Okay, so here's what I want you to do. This is how I want you to set it up every single time. You're going to write out this equation on your paper. Hopefully you're doing that right now. Write out that equation. And then wherever that equal sign is, you're going to draw a line down your paper. Okay? That line is like a wall. Things do not move back and forth across that wall. Okay? You're only working on one side of the equation. Now, the notes that I just told you said you're always going to work with the more complicated side first. Now, what do you think? Is the side with the fraction the more complicated side, or is cosine theta complicated? Personally, I think that this is way more complicated than cosine theta. So I'm going to start working over there. What you're going to do is use your knowledge of identities to make this whole thing equal to cosine theta. So what was the first step? The first step is always to write things in terms of sine and cosine. So I can't do anything with the numerator. So I have cosine theta plus 1 up in the top. In the denominator, however, I can rewrite secant theta. Secant theta is 1 over cosine. So that is something that I can change. And then that whole thing is equal to cosine theta. Miss Tompkins really wants you guys to get used to writing the equal sign and the other side of the equation every single time. Like, she wants you to be writing this out every single step that you go, so that you don't forget what you're trying to get it equal to. Okay? Now, I told you before, adding and subtracting fractions, you need to have a common denominator. So in this case, my denominator is going to be cosine theta. So this right now does not have a denominator of cosine theta. So I need to multiply the numerator and the denominator by cosine theta so that I can have a common denominator. And I'm only doing that to the 1 right here because cosine over cosine is the same thing as 1. Okay, so this fraction becomes cosine theta plus 1 all divided by, this is cosine over cosine, so in the top I'm going to write cosine plus 1 all over my common denominator, which is cosine theta. Okay, everything now is in terms of cosine, and we can go on and try to simplify that just a little bit more. So what I have right there is a complex fraction. You're going to see this a lot. I want to multiply by that reciprocal. I'm going to multiply by the reciprocal, which is down here. So I'm going to multiply by cosine theta divided by cosine theta plus 1. On the top and on the bottom. This math is not hard, John. It's just, like, you know, sometimes annoying to keep track of everything. So that stuff cancels out. And then on the top, I have cosine theta times cosine theta plus 1. On the top, in my numerator, I have cosine theta times cosine theta plus 1. Divided by, my denominator is cosine theta plus 1. And hopefully at this point you can see what I'm going to do, because our goal is to get this whole term equal to cosine theta. So I have the same thing on top and the bottom, cosine theta plus 1, cosine theta plus 1. So I'm left with cosine theta is equal to cosine theta, which is exactly what we wanted. Awesome. When you're done, when the two sides are equal to each other, just write a little check like that. Done. And that is it. That's as simple as it gets. All you're doing is manipulating one side until it's equal to the other side. I'm going to stop the video right now and then start up another one for you. Okay?